So empty space isn't empty, it's full of Higgs particles, if you like, or a Higgs field. So so this means this space, now it's not just space between the galaxies, it's in this room, that every square metre of this room is full of the Higgs field. And our fundamental particles, the electrons, let's say, in our bodies, interact with that Higgs field, and in that process they acquire mass. So it's the mass generation mechanism. It's why some particles are massive, like electrons and quarks, and some things like photons are not massive. They're massless, and they travel through the universe at the speed of light. So that's the theory. Now, that was suggested and built mathematically, essentially. There was very little evidence for it at the time, back in the 60s. But over the years, the theory, called the Standard Model of particle physics, passed all experimental tests. So we got to the point where we thought, right, okay, we will build a machine that will either disprove or prove that theory, and the LHC is such a machine. If that theory is correct, which it now seems to be, the prediction is you must find the Higgs particle at the LHC, or some kind of Higgs particle. And indeed, we found it.